really good at math. Okay? So what I'll do next, I will give you 3 examples. And these 3 examples I've taken from this book called Outliers by Malcolm Gladwell. And in this book, he basically tries to understand what distinguishes a genius from the rest of the people. Okay, what makes a person excel, compared to other people? And these are outliers. That's what the title of the book is, Outliers. Here's a bunch of people, and then somebody who's way above them. Okay, what makes this person go above? Okay? So I'll take examples. He's written a whole book about it. I'm going to take just 3 examples that I think are relevant to learning mathematics. So the first example is about this TIMSS test. It's basically a test that is taken every 4 years by an international group of educators. And it's a comprehensive mathematics and science test. And they give it to elementary and junior high students around the world, all different sorts of countries. Okay. And TIMSS, which the test called, stands for Trends in International Mathematics and Science Studies. Okay. And the point is to compare the educational achievement of one country with another's. So they give the same test to students in Japan, students in the US, students in Korea, and so on. And then when they take the average results from all these countries, they can rank which country is doing better than the other one, and so on. Now, what happens when a student goes to take one of these tests? Okay, so they sit down, but before they are given the TIMSS maths exam, okay, they're given a questionnaire, which is like a pretty significant booklet. It has about 120 questions, so it's not a trivial exercise. And the questions have nothing to do with mathematics, okay? But they are asked about, things as what their parents' level of education is, and what their views about math are, and what their friends are like, and so on. Okay? It has nothing to do with mathematics. It's, what a lot of people would consider to be a boring exercise. I'm there to take the math exam, but I have to sit, several minutes and fill out this questionnaire. Okay? So as a result, many students leave as many as 10 or 20 questions blank. They said, this is too boring for me. I don't want to do it. Okay, so they leave 20, 30 questions blank. Okay? Now, the average number of items answered on the questions, they actually vary from country to country. So for example, suppose out of 120 questions, 100 on the average, Japanese students answer 100 questions. Korean students answer 97 questions. US students answer 78 questions on the average. Okay? So they vary from country to country. Okay? Now, because they vary from country to country, it is possible, in fact, to rank all the participating countries according to how many items their students answer on this questionnaire. Okay? So if Japan answered on the average 100 items, that's number 1. Korea answered 97 items, that's number 2, and so on. So what do you think happens if you compare this questionnaire ranking with the math ranking on the TIMSS exam? Okay? And it is extremely surprising that they are exactly the same. Exactly the same. 1-to-1 correspondence between the 2 rankings. Okay? So, in other words, countries whose students are willing to concentrate and sit still long enough and focus on answering every single question, which seems like to be an endless questionnaire, these are the same countries whose students do the best job of solving math problems. So it seems that there is a connection. It has less to do with the IQ, but more to do with the attitude. And this study was conducted by accident by this education researcher named Erling Boe from the University of Pennsylvania. He was actually looking at the data of TIMSS exam, and he happened to compile the list of this questionnaire, and he found out that these 2 rankings are exactly the same. It is very important that you remember that he's not saying that the rankings are related. Those of you who are familiar with statistics may think, oh, they are correlated. No. He's not saying there is a relationship. He's saying they're exactly the same. Okay? There is no difference between the two rankings. Okay? So, what is the implication, or what are the places at the top of both lists? You will see, if you know a little bit about these countries, Singapore, number 1, Korea, China, Hong Kong, Japan, these are the top countries in both the lists. Okay? If Singapore is 1 in TIMSS exam, then the number of questions answered on the average by Singapore students is also the highest number of questions. South Korea number 2 in both the lists, China number 3, and so on. Okay? So it is a very interesting study because it has implications. If you really think about it, one of the obvious implications is that I can actually rank or figure out the mathematical rankings of these countries without having the students do a single math problem. I can just give them this questionnaire or any other task which requires hard work, okay? Not necessarily related to mathematics, and by the number of questions they answer on that questionnaire, or how much they spend time on the hard-working task, I can actually predict, which country would be number 1 in math, which country would be number 2 in math, and so on. So it is the attitude of hard work, discipline. You are given a task to do. Whether you think it's boring, whether there's the weather outside is nice, you have to go to a movie tomorrow, but right now you're given this task. If you have the attitude that whatever task I'm given right now, I'm going to do it, okay? Doggedness, okay? Discipline, then you will do math. If you take this attitude to mathematics, you will be very good at math. Okay? The second example is also very interesting. It's actually about a nurse named Renee. Okay? So what happened a few years ago, a math professor at Berkeley, University of California at Berkeley, Alan Schoenfeld, he made a videotape of this woman as she tried to solve a math problem. Okay? And in the tape, basically she's playing with a software program which is designed to teach algebra. And on the screen there are y and x axes. The program asks the nurse to punch in a set of coordinates, the x value and the y value, and then draws the line from those coordinates on the screen. Okay? So if you've done any bit of graphing techniques, you know what I'm talking about. Anytime you're drawing a graph, we draw a horizontal axis and a vertical axis. This is the x-axis, and this is the y-axis. Okay? So as she punches in different numbers for x and y, the program draws a straight line, okay, based on those numbers. That is the program she's playing with. Okay? So for example, when she typed in 5 on the y-axis and 5 on the x-axis, meaning when x and y are equal, this is what the computer did. It drew a straight line which was symmetrical, okay, at a 45-degree angle. Okay. This is the line here. Okay, this is perfectly at 45-degree angle. Because x and y are supposed to be the same in this case. Okay. So if you're a little bit familiar with some high school math, you'll realize that the computer program is teaching students about the slope of a line or the gradient of a line, how to calculate the slope or gradient of a line. Okay, the slope or gradient actually measures the steepness of the line. And recall the slope, what is the definition of the slope? It's rise over run, meaning the change in y divided by the change in x. Okay? So if here is the y-axis, here is the x-axis, that's the y-axis, here is a line, this is the change in y divided by the change in x here. Okay? So change in y, which is rise over run, that is what measures the slope of a straight line. Okay. In the previous example, since the rise was 5 and the run was 5, the slope was exactly 1. Okay, so now there is Rane trying to figure out what numbers to enter in order to get the computer to draw a line that is absolutely vertical. So the task she's given is to draw a line which is absolutely vertical, parallel to the y-axis, and in fact it superimposes the y-axis. So this is what she has to draw. Sorry, the line is a little, my y-axis is a little crooked. Here is x, here is y, and she's supposed to draw a line, a horizontal line that is going up like this, vertical, okay, superimposes over the y-axis. That is the task that is given to her. Okay, now remember, if you and let me erase this. Here. Okay. So remember, if you the vertical line has an undefined slope. Why? Because the rise in the y direction is infinite, and the run in the x direction is 0. So infinity over 0 is actually an undefined number. It has no meaning. It's not a number. So that is the task that Renee is given, and she's now actually experimenting that with different numbers. If she thinks she put different numbers in her x and y coordinate, she'll eventually get a vertical line. Okay? She doesn't realize what she's trying to do. She doesn't realize she's trying to do something that is impossible. Yeah, and because she was a nurse, it was over 5 years since she did any mathematics. This was all very new for her. She didn't know this. Yeah? So now this tape, this is actually a 22-minute tape from start to finish. From the start when Renee starts to work on this problem to finish when she actually discovers the answer, it is a 22-minute tape. It's a pretty long tape. Yeah? So as she plays with the program, she discovers that as she increases the y value, the slope gets steeper. Okay? So what she does, she changes the slope from 1 to 2. Okay? So what she realizes, the slope gets a little steeper. She says, okay, well, that's something I could do. She types in 40. So the line gets steeper still. So she thinks that as she increases the y value, the line will become steeper and steeper, and eventually it will become vertical. Okay. So she if you ever watch this tape, she talks to herself throughout the tape. She's trying to reason. Okay. So then she types in 80. So the line is still steeper, but still is not totally vertical. Okay. Then she types in 100. It's still steeper. As you can see, it is not still vertical. Okay. So now she's talking to herself. It's closer, but not quite there yet, she says. And then she sees it. Finally, after struggling with it back and forth, she sees it. Okay. A vertical line is anything divided by 0, and that's an undefined number. Oh, okay, now I see. The slope of a vertical line is undefined. Ah, that means something now. I won't forget that. Remember, it took her 20 minutes of experimentation, self-talk, to get to this answer. 22 minutes. Okay? So, until she gets the final answer. Okay? Now, this is an 8th grade math. This is easy mathematics. This is an 8th grade mathematics. Schoenfeld said, if I put the average 8th grader in the same position as Renee, I'm guessing that after the first few attempts, they would have said, I don't get it. I need you to explain it. Okay? That's the attitude of a lot of people. Okay? And in fact, to confirm this, he actually did a little bit of study. He once asked a group of high school students how long they would work on a homework question before they concluded it was too hard for them ever to solve. Their answers range from 30 seconds to 5 minutes, with the average answer 2 minutes. So meaning on the average, a person would give up after 2 minutes. They'll start working on a problem. If they don't understand it, they don't get anywhere with it, after 2 minutes, they'll give up. Okay? But Renee, she continued for 22 minutes. That's important. Okay? She persists. Okay? She experiments, with different numbers, goes back and forth, one theory, another theory. Okay? Same issue, time and again. Okay? And she thinks out loud. She's talking to herself. If you see the tape, or if you happen to read the book Outliers, you'll see that she's talking to herself. Okay? And she keeps going and going. She doesn't, she has that perseverance. She goes, okay? And she won't give up. Okay? And she knows on some vague level that there is something wrong with her theory. Her theory was what? That if I keep increasing the y value, eventually I'll get a vertical line. So at some level, as she works with it, she realizes there is some problem with it. Okay? But she won't stop until she's absolutely sure she has it right. Okay? So that is the attitude Renee displayed. So what Schoenfeld was actually very impressed with this tape. He's made a lot of tapes throughout the years, but he was very impressed with this tape. So he says there's a will to make sense that drives what she does. She wouldn't accept a superficial, yeah, you're right, and walk away. That's not who she is, and that's really unusual. Okay? A lot of students will say, oh, okay, you tell us. Okay, and whatever you tell us, oh, okay. Whatever the teacher says, that must be right. No, she wants to understand. She wants to make sense out of things. So if you want, you can go ahead and read about this in Malcolm Gladwell's Outliers, page 239 to 245. Okay? So what is the lesson we're learning from here? That you master mathematics if you're willing to try and persevere. Okay? Don't give up. Okay? Success is a function of persistence and doggedness, and the willingness to work hard for 22 minutes to make sense of something that most people would give up after 30 seconds. Okay? So you have to have these qualities, these attitudes to be successful in math. Okay? Let's look at a final example. This is also from Outliers. It's about a study that was conducted by a cross-cultural psychologist, Priscilla Blinko. And what she did, she gave a large group of Japanese and American first graders a very difficult puzzle to solve. And then she measured how long they worked at it before they gave up. The American children lasted on average 9.47 minutes. The Japanese children lasted 13.93 minutes, which is roughly 40% longer. So even though both groups of students were not able to do the puzzle, okay, an average American student gave up after 9.47 minutes. But an average Japanese student struggled with it for about 14 minutes, almost 14 minutes, which is 40% longer than they would spend. Okay? And you see, this has nothing to do with IQ. This has nothing to do with intelligence. It has to do with attitude. Okay? Japanese people have this cultural attitude that they don't give up. Okay? They're persistent. They persevere. They have patience. These are attitudes that their culture has developed. Okay? So, and if you follow international mathematics competition, you will see Japan, Korea, Taiwan, China, Singapore. These are all nations which are far ahead of other countries like US, UK and all that, because of the attitude of perseverance. Yeah. Again, this is a mention in Outliers. So the summary for the lecture is, first of all, don't be afraid to learn the language of mathematics. Don't give up easily, very important. Do not give up easily. Work hard. Nothing happens with magic. Have patience and focus. When you're looking at something, just study that thing, and with patience. It'll come. It may not come right away. It'll take some time, but it'll come if you have patience. Okay? And then, as a result, you will reap the fruits. Okay? Just remember that mathematics is not only important on its own, but it is very useful in other fields that you might go into. Okay? Economics, finance, engineering, research, pure sciences, accounting, you name it, and mathematics is used there. So if you learn these attitudes and qualities, you will become good at math. You will excel in whatever field you may choose to go to. Okay? What we will do after this, I hope that you have understood this lecture and I hope it's been useful. As we start the coursework, mathematics, where we're going to study some real mathematics, I hope that you will study it with these attitudes, with these qualities. Okay? And you will see that as you adopt these attitudes, things will become easier for you and you will become